Well, everybody, hello and welcome again back to the OpenShift Origin Community Hangout. This week, we are very lucky to have a wonderful cast of characters to talk to us about HA on OpenShift. And today with us, we have my cohort, Harrison Rips, Daneyon Hansen from Cisco, who's been an amazing contributor to the HA Puppet modules, which we'll be talking about. Jason Ford, who's just launched a service based on OpenShift Origin from the BlackMesh folks. So you can find those guys at blackmesh.com. And my perennial favorite, Steve Merrill, who is Mr. Drupal, PHP, Varnish, you name it. He's been doing everything you can possibly imagine on OpenShift for us as a contributor. So it's great to have this cast. What I was going to open with today was to ask Harrison to talk a little bit to set the stage about how deploying OpenShift works. We have a wonderful website called install.openshift.com that you can go to and quickly install. But underneath the hood, there's a lot going on. So I was going to let Harrison talk a little bit about that, and then we'll get Daneyon to talk about all the HA goodness that he's contributed back. So take it, Harrison.
Okay, cool. So, a little history on installing OpenShift. Before I got involved with Origin, probably about a year ago now, maybe a little more, we had several different ways that you could actually deploy OpenShift. But the challenge was that there was not a unified way to set these up. So if you wanted to use the Puppet module that we had at the time, you had to kind of learn the Puppet configuration. If you wanted to use the shell script that we had in an unsupported form, then you had to learn that. We had a couple of other things, and of course you could always just do it by hand from beginning to end, which was pretty complicated and time consuming. So the point of the installer, of course, was to simplify all of this. And so the first thing that the installer does is it represents an OpenShift installation in a way that can be applied to any of these installation mechanisms. So, the current installer, it understands the idea of a broker, a node. It understands the idea of a database server and a message server. And the idea is that it just asks you general questions about the deployment that you want to create, and it stores it in a uniform way. Actually, it's in a YAML file. It's very, once you've created it, you can just look in the config file, and it's pretty obvious how things are laid out. Anyhow, the next phase of the installer is once you've defined your deployment, it turns around and does the work required to sort of translate your deployment into the meaningful configuration settings for an actual deployment mechanism like our shell script or like the Puppet module. So right now, version 3 of Origin, which actually came out in December and is soon to be replaced with version 4, the Origin 3 installer could only do one very simple kind of deployment. It understood the concept of those 4 roles: the broker, database server, message server, and node. And it could only install one of each, with the exception of the node. It could handle installing multiple nodes. And all of those nodes would talk back to the same broker. So, it was sort of like the Holy Grail, and definitely a high desirability item for Origin 4. For us to be able to handle what we call our high availability deployments. And this is multiple brokers, multiple database servers, multiple message servers. And so, this is something that's been on our radar for a while. But what it was going to require was a lot of work first at the actual deployment level. Like, before we can have the installer do useful configuration management for you, we actually need the engine underneath that we can drive with that configuration. It's all well and good to say, sure, you want 5 brokers, no problem. But we didn't actually have a way to deploy and configure those brokers in a highly available, cross-redundant kind of way. So segueing to Daneyon's work, this is where Daneyon comes in. He contacted me on IRC and through GitHub with a number of pull requests, and it was kind of like, from my perspective, it was kind of mind-blowing. Like, because to me, I'll be honest with you, I'm not a Puppet expert. I got better with Puppet as I started working with that part of the installation thing. But what Daneyon did, as a community contributor was tremendous. It was like, here, I solved this incredibly hard problem for you. And so actually, as it is now, I'm working on the installer for Origin 4, and spoiler alert, it's going to support high availability deployments based on the work that Daneyon has been doing. So now is probably a good time for me to hand it off to Daneyon so he can talk about how he actually did, added that HA support to the Puppet module.
Thanks, Harrison. I guess a quick question for a newbie like myself with the Google Hangouts. Is there a way for me to share my screen? Because I was thinking we could just walk through the pull requests that actually make up the HA code.
Definitely. There's if you mouse over to the left side of the Google Hangout pane, you should see some controls. There's a green arrow that says Screen Share. So you just have to be sure you share the right monitor.
There we go. I think this should be it.
All right. Yep, we see it.
Beautiful.
Great. Excellent. So what we're looking at here is the repo for the Puppet module for OpenShift Origin. Taking a look at the master branch and all the commits and see a lot of activity going on. And if I rewind it back until early May, where you see some of my pull requests here. So let's first talk about the MongoDB pull request. MongoDB provides high availability through something called replica sets. And if we look at this pull request, and please just jump in and have me slow down if you want me to elaborate on any particular section. But just right here, updating the README so that users understand what's going on here, where we're defining Mongo port, basically a true/false for enabling or disabling MongoDB replica sets, a default replica set name called OpenShift. And then this is a key parameter, our replica set primary. So whenever we instantiate a replica set within Mongo, we want to kind of have a seed MongoDB instance, and that the primary is going to be the first replica set member within the replica set. And if you're not the primary host, you want to find out, well, what's the IP of the primary host so that additional MongoDB servers can join the replica set. And then we also create an array of replica set members. Something that I struggled, and I don't know what issue I was running into with Puppet, but you see this example here where we create the array of IP addresses and MongoDB ports. I wanted to actually just call the MongoDB port parameter here, but for some reason Puppet was just not interpolating that even when I did double quotes. And so for the initial release, instead of continuing to spin my wheels, I went ahead and are requiring users just to specify that port number. But going forward, it would be nice just to be able to pull this out and just point to this MongoDB port parameter here. And then within Mongo, we want to secure the communications within the cluster. So we have a key file that stores a key name. And then I also just created an example manifest so that users that wanted to move forward with this pretty quickly could either use or at least just reference this example manifest. What else do we have here? So this is one of the key manifests and classes within the HA work. And if we look here, we basically have an if condition. So basically, if we're enabling replica sets, we want to create a MongoDB key. We require that the OO-Mongo setup be complete and that we notify the service so that when the key is created, we restart the service. And then mongo.conf needs to be notified of the key file. There's a couple flags that it has related to MongoDB replica sets, and that is the mongo.conf needs to know about where the key file is, as well as enabling or disabling replica sets. So that's what these two execs are doing, is basically going in and adding these two flags to mongo.conf, and then restarting the MongoD service. And then the last piece of this code is again another if condition that says, if you're the replica set primary, run this Mongo command repl-set init. So we're initializing the replica set, and this is the actual command. And we have an unless statement, right? Because we, within Puppet, as you may know, we don't want to endlessly run this command if and any time the Puppet agent or Puppet apply is run. So we want to make sure that we say, hey, is basically the replica set already initiated? If it's not, then run this command. But if it is, then just skip it. The other instance is that if you're not a replica set primary, then you're just adding yourself to the replica set. And here's basically the same construct of unless issue the command, and then require these particular services or execs and so forth. So with this we're requiring that the MongoD service exists and is running, that this key file and replica set mongo.conf has been created. So we're just kind of creating a dependency chain here. And that was probably one of the bigger challenges of this particular piece of work, is just understanding all the different dependencies that Mongo has to create a replica set. And our init.pp, or basically like our top level class within the module, we're just defining all of our parameters here. That's basically what this class is for. And speaking of parameters, so and I shared this with Harrison the other day, I have a feeling that data store 1, 2, and 3 may be left over from some of my earlier work as I was working on this a few months back. And so if you do play around with this, add these parameters, for your initial run. But if you continue playing around with it, I have a feeling that we can actually pull data store 1 through 3 out of there, and everything's going to work just fine. And so it's just, I have a feeling that it's just a leftover and unused set of parameters, data store 1, 2, and 3 IP address.
I'm actually going to be testing that pretty soon, so hopefully we'll be able to figure that out quickly.
Awesome. Then the same other top-level parameters we're talking about: the MongoDB port, replica sets, and you just see some of the default settings, right? The default Mongo port of 27017. For backwards compatibility, we're not going to enable replica sets, so you have to set that to true. If you want your replica set name to be something than OpenShift, then set this within your manifest, and then again, your primary IP address, the array of replica set members, and the key file information. Last pieces of code here are within the ERB templates that we use to construct the broker.conf file, as well as a mongo.conf.plugin file. So you saw the previous setting, we just hard-coded false for replica sets. That obviously will no longer work, so we had to do a few different conditions here, right? So we're now looking at doing a top scope lookup for MongoDB replica sets. Again, MongoDB replica sets by default is false, but if it is set to true, then we're going to do a for loop here where we say, hey, or I'm sorry, not a for loop, but we're going to do a join where we say, hey, take all those IP and port numbers specified in that array of replica set members and combine them using a comma to join them together. And if this is not set, MongoDB replica sets is not set to true, then we're going to go ahead and just use data store hostname :27017. So one other piece of cleanup too that would be nice is I didn't change this because I wanted to just focus on trying to make this contribution as clean as possible, but I would see that going back and changing this from a static 27017 to actually do a scope lookup for the MongoDB port number would be a good thing, since we're now specifying that MongoDB port. So Harrison, if you're playing around with this stuff, you may want to, when you get to the point things are working, you're happy, to go back and kind of do some fine tuning, maybe go back and replace this with a scope lookup of the MongoDB port.
Yeah, definitely. And as a quick comment here, one of the reasons why Danion's contributions have been so particularly helpful is that if you don't enable these high availability features, the Puppet module still behaves the way it does now. So that's, so that gives us tremendous flexibility. The installer essentially allows you to define any number of brokers, data stores, and message servers, and decides after you're done configuring it whether or not you've actually specified a situation where we need to deploy using the high availability settings. So some of these things that Danion's pointing out, we're going to ask for after you set up all of your hosts, and we kind of look at it and say, all right, so you've got more than one data store here. So now let's get some information about the replica set that we're going to create for you.
Yeah, and to that point, Harrison, I try to make things backwards compatible. So hopefully I hit that mark and make it easier to integrate the changes into the code set. And this mongo.com plugin.erb, same exact thing as the changes here in mongo.com. One last note about this is within my GitHub repo, I have a few different branches around this Mongo work that I did. I spent some time trying to go down the road of actually leveraging the Puppet Labs community Mongo module, and just ran into a lot of problems trying to get replica sets to work with that module when authentication was enabled. And again, going back to backwards compatibility, with all this HA work to the side, you deploy a standard broker node with all the necessary services. Authentication's enabled for Mongo, and so I wanted to make sure that works within HA. And when I was trying to use the upstream Puppet Labs Mongo module, just had all sorts of problems, and I was just kind of spinning my wheels. So I decided to just take a break from that and add the necessary replica set configuration directly within the OpenShift module. So I think, I bring that up because I know that there was discussion around trying to leverage community modules, which I'm all for. I think this OpenShift module, as much as we can leverage other modules to do the work instead of building it directly in the OpenShift module, I am all for. But in this particular instance, I just had some issues, and so I decided to go down this route. The next area was around clustering the Activemq brokers. Or I guess before I go down here, back to Mongo, is there any questions, or is it pretty straightforward what we're doing here?
It's good by me.
Okay.
No, it's great.
Right.
Yeah, it's pretty straightforward stuff. I mean, you kind of, it's nice to see someone actually automate all this stuff, because it's a pain in the butt to get it working by hand.
Yeah, I agree. Yeah, and one of the next pieces of automation is a lot of the stuff that I do is OpenShift on OpenStack, and so one of the next things I'd like to work on is actually orchestrating all of this along with the necessary OpenStack configuration using Heat. So I did some of that work and had it accepted within the Heat templates and by the Heat community. but that was not any of the HA work that I did. So something high on my radar to get all this HA work included in heat templates.
Perfect. Well, maybe in time for the next OpenStack Summit.
Oh yeah, with that would be a slam dunk, unless something dramatic happens with me. But otherwise, that's work that I could probably knock out in just a week or two. Anyways, so next services that are important to us for high availability, we've knocked out persistent data with using Mongodb replica sets. The next area that is important to us is making sure all of our RPC messaging system using Activemq and Collective is highly available. Same as I walk through the code changes, same thing. We're updating the README, trying to make sure that we keep all the guides updated. I go ahead and again create an example top-level manifest with the inline notes as well as the parameters that a user would implement for providing high availability to Activemq as well as mcollective. One of the things I did here in the firewall, by default, the firewall is just looking at the port that Activemq uses between the broker and the client. Well, brokers for high availability within a cluster, they use a separate port, the OpenWire port for communication among brokers in the cluster. So we had to go ahead and open up another port there. Again, init.pp is our top-level class where we're specifying the parameters that we use throughout the module, and a few that we have is a message server cluster. Do we want to enable or disable high availability clustering for Activemq? What are the members in the cluster? So I try to kind of take the same approach with the MongoDB cluster members. So for all the services that we're going to cluster or provide high availability to, we create an array of IP addresses or IP addresses and ports. And this mcollective or mcollective cluster is basically the same thing as message server cluster members. If we feel at some point that this is redundant, no longer needed, I kept them separate just to be very specific about what services we're clustering, and then a password that we use to secure the communication within the cluster. Here's the default settings for those parameters, and then also what I do in this top-level class is also just create some conditions so that we make sure that if a user sets the message server cluster, that you also need to make sure that cluster members are set for both the message server and mcollective. So if a user went ahead and said, okay, I do want to set message server cluster to true, but did not provide these parameters, then at least they'd get an error message saying, hey, you got to make sure you set all these parameters, otherwise the Puppet run will fail. And what I'm doing here for the mcollective client class is saying, okay, cluster members, go ahead and get that parameter from the top scope, which is our init.pp. And I say if cluster members pool size equals size of the cluster members, so I could specify 6 different IP addresses to be in my mcollective and Activemq cluster. But if I don't specify it, then the default pool size is 1, which basically means that it's not highly available. And the same thing with the mcollective server, right? So this would be for, these are for both our broker as well as our node. So both the node and the broker need to be aware that we're actually configuring a pool of servers within the cluster. And then our message server class. Again, we're pulling the message server cluster members from our from init.pp. And we need to know about the remote cluster members. And to do that, we're basically doing this Puppet delete, where we take all the cluster members that we specified in that array minus the local host name of the message server. So if this is broker 1 and you've got broker 1, 2, and 3 in the cluster, broker 1 will remove itself from that array. So it's important to know that when you define these cluster members, that you're defining all the IP addresses of the servers in the cluster.
I'm totally checking my work as you go. I'm looking in my installer code to make sure I've captured all these as you go.
Cool. So now we have a condition here that would say, so if we're enabling the Activemq clustering, we're going to use a different template to set up the activemq.xml, right? We're going to call it activemq-network.xml and .erb, since it's an ERB template within Puppet. And if we don't have clustering set up for our Activemq message servers, then we're going to just use the default Activemq xml.erb to generate that that configuration file for Activemq. And by setting up this condition, we need to actually go to this file and change the content. And instead of saying, okay, we're using Activemq xml.erb, we actually are going to use a template real, which is just a way to say template real equals Activemq network xml.erb if message server cluster is enabled. And if not, then we'll go back to just the standard XML activemq.xml.erb. Let's see, and here's a template. This is going to be a big file because this is a brand new file that we added to the Puppet module. And not a whole lot here to really talk about other than when we start getting, let's see here, no, that's going to be standard, is really this is kind of the meat of it right here is where we start saying, you know, for each remote member, add the connector description and the URL to connect to that remote member. So all this is basically saying for, you know, so that, you know, broker 1 knows how to communicate to broker 2 and broker 3. And we need to know the remote members. It's why I added this code, is so that is without specifying the remote members, which was basically this delete. Let's see here. Where did it go? This right here. Right, because we don't want to set up a connector to itself, otherwise we have problems there. So for you know, the Activemq configuration file for each broker is going to go ahead and do a for loop and say for each remote member, you know, create a connector, create 2 connectors, and here's the URL for the remote, as well as a username, password, and so forth. And that's a primary piece of the code for this configuration file. Let me just kind of zoom through there. Then collective client and server configuration files, again, those are templated. They always have been, and now we're just changing it. Before, it just would use a static pool of 1, right? So that means we only have 1 broker in our Activemq pool. That's not going to work for HA. So what we need to do is change that, and so we create a you know, a parameter at pool size. And the app pool size basically took the number of Activemq cluster members that we created. And let's see here. Here's a pool size, right? So the pool size is basically size of the cluster members. So it'll count up all those IP addresses that you specify in the cluster members array, and that's how it knows how to set up this pool size down here. And again, we've got another for loop that says, for every cluster member in the cluster, add the cluster member, which is basically the IP address of the cluster, increase the index of the pool size, and then specify the user password port. And so for every member we create in the Activemq cluster, it'll just iterate over this set of code. And so if we've got a Activemq cluster of 8, 6, 20 servers, it'll keep going ahead and creating the necessary pool number and cluster member IP and so forth. This is the same piece of code for the server as we're implementing in the client. So that's all the Activemq, mcollective, high availability configuration. Any questions there? Otherwise, we'll go to then kind of the last major piece, which is providing high availability to the broker API endpoint.
So how are you on the node, on the node side? Because whenever they're checking in for these queue jobs and so forth, how's that getting pushed to actually check the multiple? If broker 1 fails, for instance, how does it know not to query broker 1 and just go to broker 2?
There's basically a heartbeat that's implemented in the mcollective client. So the way that this code is set up is that all nodes will communicate to broker 1. So if I've got a cluster called broker 1, 2, and 3, and the way that the pool for mcollective is set up is, the first pool member is broker 1, then second pool member 2 and 3. All nodes will use broker 1 until that heartbeat goes away, and then they'll say, oh, let's use the second pool member, and all the nodes will switch over to broker 2. Moving this forward, so I guess a quick background on me. And so before I got involved in OpenShift in January, I'd been doing work for a couple of years around OpenStack with high availability. So a lot of the stuff that we did around high availability for OpenStack, I was able to move it over to OpenShift. And one of the things I'd like to do with with this Activemq code is, instead of having multiple Activemq members in the pool or multiple pools, is actually just having one pool have a virtual IP address that represents the Activemq cluster, so that we could actually load balance across whatever number of Activemq brokers that you have in that cluster. Whereas right now, this is more of kind of a high availability solution as opposed to a high availability and scalability solution, because basically all nodes, all mcollective clients on those nodes are going to continue to use the first pool member, and that doesn't scale very well.
Yeah, and that's why I was asking if you were using something like Keep Alive or Heartbeat or UCARP or something like behind us to basically serve that functionality, or if you were using something like HA Proxy or something along those lines, IPVS or something along those lines, in order to do this work. In case of, because I could see instances where we would have, if you'd have 100 or 200 gear node servers sitting behind this, querying those things out, that's gonna, I don't know what that will look like yet, but if those jobs become really heavy, then that one single broker is just not going to be enough unless you put it on real hardware and then basically scale it out that way instead of using virtual instances.
Yep. Nope. I agree with you 100%. And I want to say that that I started messing around with front-ending the mcollective communication through HA Proxy, because you'll see in the next commit I did use HA proxy and keep alive D for providing HA to the API, broker API endpoints.
Mm-hmm.
And with M Collective and Activemq, I want to say I just ran into some kind of problems, and I said, hey, let's just kind of take it step by step, and so I just kind of reverted back to this configuration that we're looking at, so that we could at least provide an initial level of high availability instead of trying to do all the work myself. And so I would say, just like with some of the things I pointed out with with Mongo, same thing here with this piece of code, is it could definitely be improved. Front-ending the message server cluster with a VIP and making sure that the brokers fail over seamlessly, and I think that would be a natural next step for this code.
Honestly, I'm happy to see the HA part. I mean, we were working on that internally as well, and this is, as soon as Diane said something about this was happening, and then we kind of said, all right, well, we'll just wait for this, because that was a week and a half ago at this point. So and trying to get all this working is a little bit rough.
Yeah, and so I just try to take the approach that I've taken since working in community software stuff is, hey, Daneyon, don't try to do it all yourself, right? If you run into problems, instead of sitting in trying to solve the problem day after day or whatever it is, continue to try to keep that focus on that minimum viable product. And for this, I felt high availability. Like, if we can't achieve all the scalability stuff that I'd like to see, at least let's hit the high availability mark, get it out to the community, and start getting other people's eyes on it, and getting other people to contribute. And before we know it, we're going to see this thing take the next level up of functionality that we'd like to see.
That's what community is all about, and that's why, Ethan, you're here, and Steve's here, and a whole lot of eyeballs helping Harrison and the rest of the community get this thing done.
Yeah. So on the next commit, this was around HA for the broker API, and this is really the first commit that is really leveraging other Puppet modules. So we're leveraging the Puppet Labs HA proxy module, and then a Keep Alive D module from a contributor. So the README, just adding a new role. We now have a load balancer role, and I took this approach of roles because I kind of was going back and forth on, should we have separate servers that are load balancer servers running HA proxy and Keep Alive D? I said, but there may be some people that would want to just deploy that functionality on the broker nodes, and so I said, let's just kind of follow the same model that was used for some of these other services. And so we've got the load balancer role. We've got several different parameters that we need to be aware of for deploying broker high availability. Similar style design pattern that was used for the other functionality. We're going to do broker cluster members. So we have to specify an array of broker IP addresses. We have to create a virtual IP address to front end the actual list of IP addresses of the brokers, and then a virtual host name that gets associated to this virtual IP address within DNS. We need to know of the load balancers which one is the master, because that will set up basically the HA proxy priorities appropriately. And then we also implemented authentication so that passwords used between the load balancer members. Provided an example top-level manifest that you can use for deploying this functionality. And so you see here cluster members, the broker host names, cluster IP addresses, the IP addresses of the brokers, a virtual IP address, and in this example, this would deploy a load balancer master. Remember that all the other servers would need to be deployed as false, or just remove this because I believe the default is false. Yeah, default is false. Our top-level manifest, same thing that we just went through here, is just our parameters, new parameters that we're introducing to the Puppet module, and then the code for the new role called load balancer. Same thing here. Here's the heart of it, the new class called load_balancer. Provide example usage, some notes, and then all the details around the class. So we're making sure that we're including the keepAliveD class from the keepAliveD module. Just some logic here to make sure that if we are deploying the broker and the load balancer roles together, we need to make sure that we go into Apache and we make some changes there. And the reason for that is Apache, this particular class, the front-end Apache, it will listen on all ports. And that becomes a problem when you have HA proxy installed as well, because HA proxy, if it's running on the broker, it wants to listen to port 80. And so we need to make sure that Apache does not listen to port 80 on the virtual IP address associated to a node that would be the broker and the load balancer. So again, we say we need to define the master, and we need to define the master because if we say that a particular server is a load balancer master, then we're going to set the priority to 101. Otherwise, all other load balancer members will be set to 100. Since we are associating a virtual IP address to this server, we need to go into sysctl and say, hey, sysctl, allow a non-local IP address, right? Because it's going to be some virtual IP address that we create. Allow it to bind to this machine. And then, under the covers of keepAliveD is really VRRP, and here's all the parameters we need to set. And again, this is all exposed upstream through the parameters here that float up to your init.pp top-level manifest. And then we're doing a tracking script. Basically, this tracking script, so if we've got 2 or more HA proxy members or load balancer members, and HA proxy, was to die on one of those servers, the backup load balancer would then kick in and become the primary, and vice versa. Here's all the parameters we're configuring for the HA proxy class. A lot of this just has to do with configuring the haproxy.conf file. What virtual IP address that we're going to listen to for the broker HTTP cluster. And the balance members. So all the HA proxy functionality that we need to. And I guess something to point out here is you see we've got 2 clusters. We've got the broker HTTP cluster, and then we've got the broker SSL cluster. So when you look at the haproxy.conf file after this deploys, you'll see that we have 2 different clusters, cluster configurations going on, one for listening on port 80, one for listening on port 443. The front-end Apache, and this is basically what I was telling you, is if we are deploying HA proxy, so basically the load balancer role along with the broker role, we need to make sure we go into httpd.conf right here for Apache, as well as ssl.conf for Apache. And we need to make sure that instead of having Apache listen to every single IP address on the server, that we say, hey, only listen on the broker IP address. Because if we don't do this, then we have problems because HA proxy cannot bind to the virtual IP address for for this cluster because Apache is listening to every single, listening for 443 and 80 on every single IP address on the box. So there's just that conflict between Apache and HA proxy that we need to manage, and all of this is abstracted out. So I basically just said, if you deploy broker and load balancer together, you don't even need to worry about this. All the Puppet code is doing this for you. Just some details around the load balancer role, load balancer.pp, and all this is doing is just saying, hey, register the virtual broker DNS, right? So we call out that we need to front end the cluster of broker IP addresses with a broker virtual IP address, but also a broker virtual host name, and that makes sure that we add this to the bind server. And register underscore DNS.erb is a template that's used to instruct how to update the DNS entries for bind. And all we're doing here is just saying, if you're the load balancer master, add the broker virtual IP address. And here's basically all the DNS update code where we're just saying here's the name server IP address, the virtual host name of the broker cluster, and the actual A record is right here. And then we issue DNS or NS update. So again, the three areas that was focused on was Mongo, Activemq, mcollective that work hand in hand, and then the broker API. One area, so if we go back here, pull request. One area that I also worked on, but kind of ran into a bit of an issue, was trying to provide high availability to bind, or the name service. And so maybe take a look at some of the communication here, the commits, the file changes, and play around with this if you get a chance. And basically, the issue here that I ran into is that to provide name server HA, we need to do a couple things. We need to use Power DNS. I looked into both bind, I think it's bind 9, as well as Power DNS, and it seemed like Power DNS is our only option for providing high availability for OpenShift, because it also supports dynamic DNS updates. And so this is an area that it'd be really nice to get some contribution on, is having some folks work on making this work properly, because right now this still is a single point of failure. So when I went down this road, I figured, okay, we could provide a basic level of high availability where we create, bind master slave setup. Well, if the master goes down, the slave should still be able to respond to DNS queries, but you just would not be able to deploy or delete applications, because part of that process is dynamically updating the DNS name for that application, or removing that DNS name for that application, and that becomes a problem. But the bigger problem is that within the plugin for bind within OpenShift, it only supports a single IP address. And so we'd have to front end the Power DNS cluster with a UDP load balancer. And again, this is all work that can be done. I can do it. I would at least like to have some help with, packaging up the Power DNS code into packages that are maintained on, the Origin nightlies or wherever we'd want to put those, if that's the direction that the community agrees to go down.
Right. Yeah, a couple comments I'd like to throw in on this. So ultimately, Daneyon put a lot of effort into making sure that each of these HA components, if it's not turned on, then the system behaves the way it does now. And so for that reason, I am going to be merging that pull request that Daneyon put together for HA name server. That said, DNS is very complex, and what we're finding is that it's very hard. Like the installer that I'm writing is trying to do the smartest deployment that suits the most use cases. And named is like the one space where it just gets really hard to get that right. So essentially, while that is going to be available through the Puppet module, OInstall is going to continue to basically just offer two options. One is it will install a single bind instance on one of your brokers, and it will create dynamic zones there for your applications and optionally also for your OpenShift component hosts. Or alternately, you can tell it where your DNS lives and what DNSSEC key to use, and it will just talk to an external DNS. So that gives you the option of basically solving an HA name server problem outside of the scope of OpenShift by setting it up somewhere else. Or alternately, if you want, you can take our Puppet module and even use our installer to build. One of the things you can do with our installer is just build the Puppet templates without actually deploying them. So you could do 99% of the work through the installer, and then if you want to enable the Power DNS stuff that Daneyon has added, then you can go into the templates that you created and make those changes there. So, and that's because we want to support Daneyon's efforts here. Having HA DNS is sort of like the last thing that we needed, but which is to say we needed it, not the last thing. Not like, man, we totally don't need that. We totally do, but it's just really it gets very, very sticky to try and capture every case in a meaningful way in the installer and still have a good user experience with the installer and cover most of the cases. So we're opting in the installer design to say we're just going to do two very basic things and give you the tools to enable these more complex things if that makes sense for you in your deployment.
Yeah, so just to add to what Harrison mentioned, so the bind HA code that is sitting there as a pull request, I think the easy fix would be is to play around with it, get it working, and it will work just fine. It'll set up your master, your slaves, but what you'll find out is when you fail over the master, things don't work the way you want them to. The easy fix is to put a UDP load balancer, in front of the DNS IP addresses, right? So instead of specifying, a standard resolve.conf where we've got, DNS server 1, 2, and 3, and that's the way that the Puppet code was set up, we would just have one entry, and that would be an IP address of a virtual IP address of your DNS cluster. The challenges you have with that is still if that master dies, you're going to find that you're not going to be able to deploy applications or delete them because of that, because the way dynamic DNS works, it will not do that on your slaves, right? And that's where I get to Power DNS. So, if the bigger body of work is to go ahead and say, okay, let's move this to Power DNS or support multiple backends. I mean, even though the backend is called the named server backend or something like that, from my understanding is as long as Power DNS follows the same RFCs for dynamic DNS, everything should work just fine. And so, long story short, play around with the DNS HA code. Simple fix to get it to work is to stand up a UDP load balancer and just use a virtual IP address, and I think you'll get most of what you want accomplished. But longer term, it would be nice to get some work around Power DNS and do the DNS stuff the way we'd like to do it.
Yeah, the only other way that I know to do it is also do a MySQL backend for bind, which is a little bit yucky, but at the end of the day, it does work, and you can do some replication behind there and have both of those pull, and then you still have the DNS. You still have to have the load balancer in front of it querying those things, but at the end of the day, you'd have everything in just much like Power DNS is doing with a database backend.
Yeah, Jason, and do me a favor, take a look at it, because I looked at using the MySQL and actually started implementing it and playing around with it. The challenge that I saw and what appears to still exist is that the dynamic loadable zones, the DLZ functionality within bind, is not there even if you use a MySQL backend. And so that kind of brought me back to Power DNS, and I'm like, okay, Power DNS is the only thing that we could have multiple masters, support a backend, a MySQL backend, and I've done the Galera work already for MySQL. So if you look into Power DNS, or if you find another option that just can meet our requirements of it needs to support multiple masters, and we need to support dynamically loadable zones. The only thing I found was Power DNS to do both of those. And what I've done the MySQL Galera work already, so to cluster that MySQL backend, that's already done.
That's easy.
Yeah, and so take a look at it. If you find something differently, I'd like your feedback, but I started going down the paths of both Power DNS and bind with a MySQL backend, and just found that bind still does not support dynamically loadable zones, which is really key to OpenShift. So unless you guys find something different, I would go down the Power DNS route. You could ping me on, I'll share the Galera Puppet code with you, but first step would be just packaging up the Power DNS package, because what comes with CentOS 6.5 and most distros, it doesn't support the code that's needed within Power DNS for the dynamic loadable zones using a MySQL backend.
Right.
If that makes sense at all.
Yeah,
Wow.
it does. Yep.
I kind of feel like we've just had a master class in HA, Puppet, and installation. It's been pretty amazing, and what a great deep dive into everything. Daneyon, I can't thank you enough for the work that you've done, and I know it's going to take on a new life too once we get a few more pieces in place, especially in Origin v4, as Harrison tests all this out and makes it work, and if we can get Jason and the folks at BlackMesh looking at it, and Steve Merrill testing out with some of his clients, I think we'll see some really awesome HA and hopefully the scalability too coming very, very soon. So we've just hit like the 1 hour mark, but I think we could talk about it for another 2 hours because it's such an interesting subject, and there were lots of other things that I wanted to bring up and talk about today. So I think we're going to have to schedule a few more of these Google Hangouts, and wanted to maybe, Daneyon, if you hang on for a few minutes afterwards, I'm going to stop the broadcast now, and we can check in and make sure you're getting everything else you need for yourselves at Cisco, and I'm sure the other guys would be interested in what you're doing as well. It's 1 hour is about the maximum limit anyone will watch one of these videos, even though you're all so wonderful. So, thank you all. You can catch everybody here on the OpenShift-Dev IRC channel, or ask one of us, and we'll hook you up with all the contact information. So thanks, and I'm just going to stop, but hang on, guys.